All right. So welcome back, everyone. I hope you all had a good spring break. I know I had a good spring break. I hope you all did something fun. Um, but yeah, so this is week 3 for Intro to Backend, and today we're going to be learning about relational databases. So first, for some announcements, I don't know if y'all saw on the ed, but PA2 deadline has been extended until Wednesday. So you guys have at least 2 more days to do that before the slip days start coming in. And yeah, so the office hours were already posted on ed, and then the PA1 grades are coming soon. And if you have an issue with how your PA1 was graded, your PA1 will come with like a text file with the person whose net ID graded your assignment. So if you have an issue with how they graded it, you can just reach out via email to them and kind of explain like what kind of make your argument for why you think you should receive a better grade, and that's going to kind of work as like a regrade request in a sense. So I know it's been a pretty long time since we've done backend before. So we're going to go into a little bit of a review of the client server model. So we have the client over here, which is basically just the phone, tablet, or computer that the user is using to send requests. And the server is a large computer that runs backend code and handles all of the data. So as I said before, the client sends a request to the server. Some route is triggered. So if you remember, the route is kind of that URL that you're kind of sending requests to. And so this route is triggered. Some data operation is performed. Usually it's a CRUD operation. You're either creating a user or getting all users, something like that. And then, yeah. So yeah, the CRUD operation is performed. Then the server sends an SQL command to the database. And this is kind of like getting, I guess, querying the database for this information. So we have the SQL command going to the database, and then the SQL command, or I guess the database, then returns some data back to the server. So if you're like getting all users, the database is going to return all of the users back to the server. And then the server is going to return a response back to the client. So I guess a big overview is that the client sends a request to the server. The server then sends some sort of SQL command to the database and kind of queries the database. The database then sends data back to the server, and then the server sends a response back to the client, which then front end uses to, I guess, make a nice user interface for the client. Oh, all right. All right, good. All right, there we go. All right. And again, I guess in week 2, we were using kind of like a single table database, but in general, databases are, again, multiple tables. So like if you have like a users table and a posts table, those 2 tables consist of the database. Each of those tables is not like a separate database. So when we were using this single table database last week, the tables structure information into like rows and columns, and they kind of represent like an Excel spreadsheet, where if you're like querying information, you can kind of drag your cursor along the Excel spreadsheet. You can query different information. That's how kind of SQL interacts with the database. And yeah, so like the Excel spreadsheet, the columns represent like a field with a defined type. So like, let's say a net ID, it'll have some sort of like string data type. And each column has all the different net IDs of, let's say, the different students that are in your table. And the rows represent a collection of column values. So like, let's say each entry is like a particular student. And then, yeah, we use SQL to query and manipulate data. Yeah. So in the last 2 weeks, we covered routes and then a very like high level overview of databases. And this week, we're going to be covering relational databases. And so does anyone have any questions, first of all, of like the material that we've covered the last 2 weeks? All right, that's good. So now we're going to cover relational databases. So these databases allow different relationships between data. So if you remember in PA1, you could have several comments for one post, right? But the way we were implementing it, we had these like 2 dictionaries, and it wasn't a very efficient way of like relating these 2 things. So in general, if we have like a database, the relational databases allow us to kind of relate comments to different posts, right? And so again, let's say we have like users in Instagram. we have some users that are different friends of other users, and those friends have other friends that may not be the friends of the other user. So how do we actually know which users are friends within Instagram? And then for PA2, we can use this to like say which transactions relate to which senders and receivers. So yeah, so here we have like a user table and a post table, and we see that we have two users in here, me and Ayush, and we see that we have a post table and it has this user ID column over here. And so we see that this user ID refers to the ID of the user in the user table. So we now know that this post over here, the deleted eatery code base, corresponds to Ayush's I guess name. So we know that Ayush made that post. And this is kind of like the foundation for relational databases. This is how we're able to relate, I guess, two different entities within tables. And so yeah, that user ID over there was called a foreign key. And yeah, so the foreign key is a column in one table that uniquely identifies like a specific row. And this is also called the secondary key. And in the previous example, the primary key is the original like ID in the post table. And then the foreign key or the secondary key is going to be the user ID. And this user ID was referring to the ID of the users table that was kind of identifying the unique user. And so this is how we were able to relate like a different post to a user. And yeah, so a foreign key column, this kind of indicates a relationship between two tables. So there's three types of relationships. There's one-to-one, one-to-many, and many-to-many, and we're going to go over all three of these today. So for a one-to-one relationship, let's say we have two tables, tables A and B. And so we have row X in table A refers to only one row in table B. And likewise, row Y in table B refers to only one row X in table A. So a good example for this is like students and net IDs. So each student, I guess each Cornell student has a unique net ID, right? No multiple students can have the same unique net ID. And a student cannot have like multiple net IDs, right? So each unique student has a unique net ID. And so this is like a good example of like how a one-to-one relationship logic kind of works. So yeah, so over here we have a user ID table and a net ID table. And so we see that the two users are me and Ayush, and we see the net IDs over here in the net ID table. And so this user ID column over here, like in the previous example, kind of relates the net IDs over here to the users in the user table. So we see that the person with net ID 10, which is me, that shows that my net ID is AKM99. And then we see that the user ID of 20, which is Ayush, has a net ID of AA2328. And so this is kind of like the SQL, I guess, query to like how to create a one-to-one relationship. So I guess the first thing we have is like a create table user. This is really similar to what we had 2 weeks ago. We just have an ID, a user ID that's, I guess, integer primary key auto increment. So like a little bit of review. Integer just means it's an integer type. The primary key, that's the unique identifier. And the auto increment just means that whenever we're adding a new user, their, I guess, ID goes up by 1. And we have a name that's some text, which is not null. And then so this net ID table over here, it's basically the same, except we have these two new fields, user ID, which was on the example. And this is an integer unique. And the reason why we put unique over here is that we only want one unique user ID for every net ID. If we didn't have this like unique keyword over here, we could have like multiple user IDs. Like if we go back over here, we could have, let's say, two user IDs of 10 in here. So if there was like a different net ID over here and that said 10, that would mean that I would have two net IDs, which is not possible. So this is why we have the unique keyword over here. And then the last thing over here, this is what allows us to actually create the relationship. So we have these three keywords over here, foreign key, user ID. This essentially says that the user ID is a foreign key, and it references the ID column over here in parentheses of the user table. So if we go back, we see that this user ID is referencing the ID column of the user table. And yeah, so this is how we can insert like data into our table for the one-to-one relationship. So we just insert a value, which is my name, into there. So we have one user in this table. And then into the net ID table, what we're inserting is a net ID and also a user ID, which is kind of relating which user this net ID is relating to. So we see that we're inserting AKM99, and then the user ID is 1. And this is relating me, which I'll have I'll have an ID of 1 since there's no data in here. And this is going to relate the net ID of AKM99 to my name. And so the next relationship is a one-to-many. So this is basically saying that row X in table A refers to many rows Y1, Y2 in table B, and row Y in table B refers to one row X in table A. And so a good analogy for this is like you have baseball teams and players. So let's say the baseball teams are table A and the players are table B. So each team can have many players, right? A baseball team, I don't know, has 20 something players. But each player only belongs to one team, right? You can't have one player playing for the Blue Jays and the Astros. You can only have one player playing for one team. And so that's kind of the logic behind the one-to-many relationship. And so this is also illustrated by like songs and albums. Let's just assume that like each song like only occurs in one album. So we have these two albums over here, Igor and 444. And in this song table, we see that now we're allowed to have multiple, I guess, oh, that should be song IDs or album IDs. But we have two album IDs of 10, and that relates these two songs over here to the album table over there with the album name Igor. And so that tells us that those two songs belong to that album. And then for 444, we have this album ID album ID of 20. And this is going to reference the 444 album name in the album table. Yeah. And so this is kind of the sequel for like how to create this one-to-many relationship. So for the album table, we just have like an ID and then just the name of the album. And then we have a song table, which is pretty similar to how we created the one-to-one relationship, except the main difference is that instead of having integer unique for the album ID, we have integer not null. And this is what allows us to have, I guess, multiple songs to be related to one album. And then at the end of the song table, we have that foreign key album ID references the ID column right here, or I can't really point to it, the ID column of the album table. And so this is what relates album names to song names. And yeah, so if we want to insert something into like song table, we have like a name and an album ID, and we're inserting Earthquake and the album ID of 10. And then this is going to relate this to, I remember, yeah, to the Igor album. And then if we select all from song where the album ID is 10, we should be able to get this song Earthquake over here. And this is basically going to retrieve all of the songs that we have in our table with the album ID of 10. And this is how we get all of the songs that are like part of an album. And so the last, I guess, big relationship we have is a many-to-many. And so as I guess the name implies, row X in table A refers to many rows Y1, Y2 in table B. And then row Y in table B refers to, I guess, many rows X1, X2 in table A. And so a good example of this is like students and courses, right? So each student can be in many courses. So like I'm enrolled in 4 courses right now. But then each course, which I'm in, has like hundreds of students, right? So each student can be in many courses, and each course can have many students. And so that's the premise behind the many-to-many relationship. And so to implement this, there's 3 potential choices, and the first 2 aren't really that ideal. So the first way is to have like multiple columns to store like more foreign keys, which we'll show that in a second. And the second way is to have like a single column to store a list of IDs. And then the third thing is like a join or association table, which we'll go over all 3 of these. So the first, I guess, way we can try to model a many-to-many relationship is to just have a bunch of courses as like foreign keys, right? So let's say we have these two students over here in the student table. They're enrolled in 3 courses. They're different over there. And I mean, at first glance, this looks, I mean, okay. There's no wasted space and everything looks decent. But let's say if a student wants to enroll in more than 3 courses. So we have this student GG387, and he's enrolled in 5 courses, right? So we don't really have columns for these 2 courses at the end. So what are we going to have to do? We're going to have to make these course 4 and course 5 columns over here. But the first 2 students aren't enrolled in 4 or 5 courses. So all that information over there is going to be null. And likewise, if someone is only enrolled in 1 course, they're taking like a light semester or something, then all of the course 2 through course 5 fields are also going to be null. So I guess this demonstrates that when you're trying to implement a many-to-many relationship using this method, you're going to end up with a bunch of wasted space, and which isn't really good if you have like a giant database with, millions of entries and stuff like that. And so, yeah. So then the next example we have is we try and store like a bunch of, I guess, IDs or course IDs within like a list. And then we relate them to like students over here. So we have, I guess, the student SN685 is enrolled in 2 courses, 1110 and 1998. And then JZS27 is enrolled in 1110. And we see that in the course table, CS 1110 has 2 students, and then CS 1998 has 1 student. And yeah, so these are just basic foreign keys over here. So, but what if we try and add someone else, GG387, right? So what we're going to have to do in this case is we're going to have to go through the courses table and iterate through every single course and manually like insert that this student is being enrolled in this course, right? So we're going to have to append student 3's ID to CS 1110 and also CS 1998. And so you can probably see here that let's say we have like hundreds of thousands of students and hundreds of thousands of courses. So if we're iterating through hundreds of thousands of courses for every student that we're adding, we can see that this becomes pretty like time inefficient. And yeah. So I guess the way to solve this, so we had like a space issue where we just have like a bunch of space that's not being used, and also like a time issue where if we're not like trying to, I guess we had that space issue, we try to get around it with iterating through all the courses, which isn't good. So this is where the join or association table comes in. So what we have here is we have a student table and a course table. And right now in those 2 tables, there's no foreign key in them. There's simply just an ID and a net ID. And then we have an ID and a title for the course table. And so what this association table is, it's basically just a table relating these, the student and the course table, except each column in the join table is a foreign key. So what happens here is we have a student of ID 1. If we want to find what courses they're enrolled in, we go to the join or association table, and we see that they're enrolled in 1110 and 1998. And then this relates to the course table over here, and we see the title of those courses. And then if we want to see all the students that are enrolled with the course ID of 1110, we simply go to the association table and just query, we can say like select all from, I guess, this table association where the course ID is 1110. And we just get the student IDs of 1 and 2, and it relates them over here. So we see that this join association table, it allows us to, I guess, query information and also relate to, I guess, tables with many-to-many relationship really efficiently. And yeah, so let's say student 2 enrolls in CS 1998. All we have to do is simply just add an extra entry in the association table, and the relationship still holds. There's no errors or nothing like that. So it's really easy to just insert new data into this, I guess, schema over here. And so the way we implement a many-to-many relationship in terms of SQL code is we have a student table and a course table. We just have an ID and a net ID for the student table and an ID and a title for the course table. And we see that there's no foreign keys yet. But then when we go to this join table over here, so we're going to have like the ID of like the entry. This is going to be like a primary like identifier. Sometimes this isn't really relevant, but you always need a primary identifier. So we just have that there. We have the course ID and a student ID, and those are the two fields that we're going to be relating the student and the course table from. And we see that each field or each column in here, other than the primary identifier, is a foreign key. So we see that the course ID references the ID column of the course table, and the student ID references the ID column of the student table. And so this kind of creates the many-to-many relationship. And so we have a model between students and courses. And so, yeah, I know I went over like a lot of stuff pretty fast. So if anyone has any questions, feel free to ask. But if not, we can just head over to the demo and we'll be kind of showing you how to implement those live. All right, all good.
All right, hey everyone. Hope you guys enjoyed your break. Saw the eclipse today. My opinion wasn't that great, but it doesn't really matter. So let's get into the demo. So as Tony talked about, there's three types of relationships. There's one-to-many, or sorry, one-to-one, one-to-many, and many-to-many. And we just increase the size. So we're just going to be going through and just creating those tables for you guys, just to give you a concrete example of what exactly we're talking about. So we can just start with creating the SQLite, just entering the shell. So just typing SQLite 3, that'll launch the SQLite shell, and then we can create our own tables in there. So the first one we'll implement is the one-to-one relationship. So as Tony went over in lecture, the way we do this is with a foreign key that has a unique modifier. So one foreign key can only reference one other key in a different table. That's the way we constrain it to only one-to-one. So to do that, we'll first just create our tables. So we're going to be doing a user to a profile. So we'll have an entry in our user table that'll contain just their name. And then we'll have an entry in the profile table, which contain like net ID and their user ID as the foreign key. So to do that, first we do create table. We'll just call this user. Then we can hit enter to go to new line. And we always need an ID for the primary key. So we'll just, ID is an integer, primary key, and then auto increment. And then, like I said, we'll just have a text, a name field, which is just a text. And then, yeah, that's our first table, the user table created. And now let's just create the profile table. So create table profile. And then in this one, we'll have the same ID. I misspelled create, so I'm just going to redo that command. So create table profile. Then ID integer primary key auto increment. This one will have a net ID, which is also text, which is not null. And then we'll have the user ID, which is the actual foreign key. And then, as we said before, this one has to have that unique modifier to constrain it to only one-to-one. And then we'll just say right here that it is a foreign key, so that SQLite knows. So the way we do that is by typing foreign key and then in parentheses user ID, and then references. And then from the user table, we select a field in there, so user ID. And then we can come down here. And now we've created both our tables, the user and the profile, and we can check that just by doing the .tables command. And then we'll have these two tables. So just giving you a little bit to copy that down. So now we actually want to insert like actual data into our tables. And for this, the way we do that is just the insert into command. So insert into, and then let's just first create our users. So we create insert into the user table, and then we provide a name and values. Then here, does anyone want to volunteer? Just say their name. You just add to the table. You can guys can be part of the demo. What's your name? Felix. So Felix, insert him into the table, and then just one more, insert into user, same exact thing. Anyone else? What? Oh, yeah. David. So we have Felix and David in our table now. So we've inserted these into our table. So now we can like select all from the user table just to see you guys. Select, make sure you spell select correctly. And so we have Felix at ID 1 and David at ID 2. And now let's actually create their profiles too. So insert into profile, we'll give in a net ID and a user ID. So Felix, what was your net ID? FJG45. Yep. And then we see your user ID is 1. So we can just provide that too. So just put a 1 at the end there. And then insert into, a quick way to do this is you just hit the up arrow key and you can get the entire thing back. So now we'll be inserting David's net ID, which is DEV38. Yep. So now we've inserted both of the profiles in, and we can just check that by select all from profile. And so the fields of this profile table are the actual IDs of the rows, and then the net ID, and then the actual key that it's referencing. So it references 1 in the user ID table. And now we can see that since we constrain it to unique, we can't insert anything else that references back to like the user of ID 1 or user of ID 2. So if I try to say Felix's ID is now instead my net ID, so if I come in here, I say A2328. If I try to change that to mine, we should get an error because the unique constraint has failed. So in that way, we can constrain it to only one net ID being to one user, or one profile being related to one user. And that way we can create a one-to-one relationship. Now we can move on to the one-to-many relationship. So we just finished one-to-one. And to that, we'll just create a relationship between a user and a post. So first, let's just create a new table. Create table post. And then the same thing, integer, the ID is an integer, it's a primary key, and you auto increment it. Let's just say each post has a description as well. So text, not null. And then also it'll have a user ID, because the way we do one-to-many as well is through a foreign key. And this will be our foreign key here. So integer, not null. And then we want to tell SQLite that it is a foreign key. So is it a references? And then from the user table, we select the ID. And then that'll create the post table. And then we can just check that by doing dot tables, which will list all the tables here. And so we had the user and the profile from the one-to-one relationship, and now we just created the post table. So now we can create some actual posts for the users. So let's just insert into the post table. We'll give it a description, and the user ID, and then we can have that, and just let's link it to user ID with ID 2. And then this can really be anything you want. I'll just say, I love backend. So this is basically saying David created a post that says he loves backend. So we can do that. Then we can create a post for number 1. Does anyone have anything to say? Any posts you guys want to make? It could be literally anything. Yep. Solar eclipse, yeah. Yeah, there we go. And then just one more, just to show that we can have many posts related to one user. No solar. Yeah. Okay, no solar eclipse. Yeah, so now we have our three posts. One is linked to Felix's user and the other, I'm sorry, two are linked to Felix, one is linked to David. So we can just select all from post just to see that. So we have the ID of the post here, we have the description, and then the user that actually references it. If we scroll up, the user with ID 2 is it's up here, it's David. And then these ones were both created by Felix. So now we can see that since we didn't use that unique constraint, one user can have multiple posts here. So that way we can create a one-to-many between a user and many posts. And kind of like an easy way to keep track of that and like know what type of relationship it is just like kind of saying it in English. So like a student has one net ID, a net ID has one student, right? That's kind of like an easy way to say it. That way you know it's a one-to-one. But if instead you have like a user can have many posts, a post can have many users, the second sentence doesn't really make sense because a post can't have multiple users like posting it, right? So in that way, you can kind of like piece together what type of relationship it is, just like pretty easily. And then finally, we can move on to the many to many relationship. So this way we'll be creating like one post can have a hashtag and a hashtag can have many posts. So we'll first create the table for hashtags. Hashtag. And then again, this will have an integer primary key, auto increment. And then this will just have a name that's text, not. And then let's just check that table exists. So now we have the hashtag post, profile, and user tables. So yeah, the way we implemented this in the lecture is through a join table, otherwise called like an association table. Really, the name of it can be anything. It's just the purpose it is. So I'll just call this one feed. So like in your feed, you have a post that can have many hashtags, and you can have a hashtag that can have many posts. So let's create that join table. So create table feed. Then of course, this one, you always kind of start off with this integer ID. The primary key, you auto increment it. And then the way we did this in lecture, you kind of have two foreign key tables, one for the post and then one for the actual hashtag. So post ID is an integer, not null. And then hashtag ID is also an integer that's not null. And then we just tell SQLite that they both are foreign keys. So the column post ID is a foreign key that references post ID. And then the column hashtag ID references the column hashtag ID. And then we can create that table, and then let's just double check that the table actually exists now. So now we have a feed that'll relate a hashtag to a post and a post to a hashtag. So just to test this out, we can create a few hashtags and then we can link them to each post that we created before. So insert into hashtag, we can give into the name column, we can give it some values. So the first one, so I'll just say the first tag is software for like our first post that was I love backend. And then we can insert into here, like, I don't know, space, I guess. So now we can just select all from the hashtags just to check. So we have our software hashtag and our space hashtag, and then we can select all from posts just to see like the actual posts here. And now the way we can kind of like join these two together is by inserting into the actual feed table, which is our join table. So we can insert into feed, we insert into the post ID column and the hashtag ID, and then we give it the values. So I'm going to link the software hashtag to the first post. And since they both have ID 1, we can just do 1, 1 right there. And then we can do the same thing, except The second post, the solar eclipse post, will be related to the space hashtag right here. And then the third post, which is no solar eclipse, can be related to space as well. And then, yeah. So now we have our actual like hashtags and posts like relationships wise. So now we can select all from feed. And this will actually just give a bunch of numbers, which is very cryptic, but that's kind of how like SQL can kind of understand how we actually like, link these two together. And just we're not going to get into it into like this course, but if you go on to learn more about SQL, we can do something called like an inner join to kind of say exactly which two are related. So you don't have to actually use this in the assignment, but this is just a command so that you guys can see the actual um, like posts. So feed energy. And okay, yeah. So this is kind of the way you can like see it. So I love backend is now related to software. I think I wrote something wrong. Yeah. But basically you can convert those numbers into actual like English using like a bit of like SQL commands. But you guys don't actually we don't have to actually get into that. That'll be like if you want to go in the future and learn more SQL. And now and yeah. So now that we have like the names of the user and their posts and the hashtag, we can actually see that like all of them are like associated. So again, since like a post has one user, but a user can have many posts, and a post can have many hashtags, and a hashtag can have many posts, we can kind of link those three together. So a user can have a post that has many hashtags, and we can kind of search all the posts that a user has made kind of through this relational system through foreign keys and the join tables. And that's kind of like the power of SQL and using relational databases is that you can link all this stuff together with just like a few commands and a few insertion tables and really get like all the data collected in like one command. And yeah, the last thing I want to say is that like SQL, it can be typed in all lowercase, but usually the convention is to type in all uppercase just because it's easier to see the actual SQL command versus the name of tables or like the values you're inserting. And that's something we will be looking for on the assignments, which is part of the styling rubric. So we just want to make sure you guys know to always do like uppercase just so it's easier for us graders and also so that you guys can know like the difference between commands and the values. So yeah, that was it for the demo. Then we can get into the actual Kahoot. So stop the sharing.